Hello and welcome back. It looks like we've got another geometry question here. Let's have a look. An ice cream shop sells two types of cones. One is 6.5 centimeters tall with a radius of 2.2 centimeters. The other is 7.5 centimeters with a radius of 1.7 centimeters. By calculating the slant height of each cone correct to 2 decimal places, determine which cone, not including any ice cream, has the greater surface area and by how much. Okay, so for any geometry question, if possible, it's always good to draw a diagram. So these are cones. So if we draw an upside down triangle like this, the first one we have a height of 6.5 and we know its radius is 2.2. The other cone, it's a bit skinnier and it's a bit taller. And the radius of that one is 1.7 and its height is 7.5. So first we want to work out the slant height of each cone. So if we cut these in half, we know that these make right-angled triangles. So this is just an application of Pythagoras. So let's do that here. We'll have c squared equals a squared plus b squared. C squared, our hypotenuse, that's unknown. We know our a value. That can just be 2.2 squared plus 6.5 squared. So c squared will equal, I'll let you guys work that out. You done? Okay, good. Did you get 47.09? Good. Now, we don't want c squared, we want c, we want the slant height. So c will equal the square root of 47.09. That'll be 6.86 centimeters, of course rounded to 2 decimal places. Now we have to do the same thing with our other cone. So c squared equals a squared plus b squared. C squared will equal 1.7 squared plus 7.5 squared. C squared will equal, I'll give you guys a bit of time to work that out. $59.14. Good. Alrighty. And we don't want c squared, remember? We just want c. So we do the square root of both sides and we end up with 7.69 centimeters rounded to 2 decimal places. So we've got the slant height correct to 2 decimal places. Now we have to work out the surface area. So the surface area of a cone is normally equal to pi times radius times slant height plus pi r squared. But in this case, it's a cone with an open end. So that circle on top won't be there, otherwise you wouldn't be able to get any ice cream in, and that would be a terrible ice cream cone. So we don't need that bit there. We're just working with pi times r times s. So if we substitute what we've got, we know pi times the radius of our first cone, that's 2.2, and our slant height is 6.86. So I'll give you guys a bit of time to work that out, and we can work out the surface area of the other cone the same way. We only need pi times r times s. And we know what the radius and slant height is. The radius for this one is 1.7 and the slant height is 7.69. Alright, I'll give you guys a bit of time to work that out. Alrighty, so for the surface area of our shorter cone, but it's a little bit wider, that was 47.41 centimeters squared. And the surface area of the other cone, the taller, thinner one, was 41.07 centimeters squared. So we've worked out which one's greater, but we haven't done by how much. So always make sure when you think you're done or you've done a step, just read back through the question and see whether you've answered everything there. So we want to compare how much greater the surface area is. So that'll just be 47.41 minus 41.07. And that gives us 6.34 centimeters squared. So this is a worded question. Let's give it a worded answer. Here's an arrow, and it can't be confused for anything else. It's definitely an arrow. Alright, and there's just an example of how practice makes perfect. So this one, it's a worded question. Let's write it down. So the cone with height 6.5 centimeters and radius 2.2 has a greater surface area by 6.34 centimeters squared. And that's it for today. Thanks for joining me, and I'll see you next time.